All right, let's go on a bit of a journey. We're going to start with something super simple, a shape we all know, and see if we can end up at, well, the architecture of the entire universe.
Yeah, I'm talking about a simple square, a shape you've known, forever. How can this humble, four-sided figure—
How can it possibly hold the key to understanding everything? I mean, from the space we live in to the flow of time itself, even the basic laws of physics? Look, it sounds kind of crazy, I get it. But the logic behind it is, well, it's actually beautiful. So let's dive in.
Okay, so first things first, we have to start with why the square is just the perfect place to begin this whole thing.
I mean, think about it. The square is like the definition of order, but in a flat, two-dimensional world. You've got four equal sides, four perfect right angles. It's just flawless balance. It's a symbol of stability, of being able to measure something, of pure rational thought. It's our ultimate starting block.
Okay, so now we're going to take that perfect 2D shape and give it a little push, a new direction to go. Let's see what happens when it literally leaps off the page. So if you just take that square and pull it straight up, right, perpendicular to its surface, bam, you get its three-dimensional big brother, the cube. And it's this really cool structure, right, made of 6 identical square faces. It's the perfect object for the 3D world we can actually see and touch.
And right away, the cube becomes this powerful symbol for our physical world. I mean, it represents width, height, and depth, the 3 dimensions we live in. Way back, ancient cosmologies used it to symbolize the solid Earth. And even today, in modern physics, it's the go-to model for everything from salt crystals to the basic structure of atoms.
So we've gone from a 2D square to a 3D cube just by following one simple rule. What happens if we do it again? What if we apply that same exact rule one more time? This is where things get really interesting and move beyond what we can actually see. Just imagine that whole cube moving, just like the square did, but it's moving in a new direction, one that's perpendicular to length and width and depth, a direction we can't even point to. What kind of shape does that even create?
Well, the answer is something called a tesseract. You might have heard it called a hypercube. It's basically the 4-dimensional version of a cube. Now, we can't actually see it in 4D, but we can imagine its shadow in our 3D space. It often looks like a smaller cube kind of floating inside a bigger one, with all the corners connected. It's a trip.
But here's the thing. This isn't just some abstract math game. Physics actually gives us a really powerful way to think about this fourth dimension, time. You see, in what's called Minkowski spacetime, you're not just a 3D object sitting here in this one instant. Nope. You are a 4D object. You're kind of like your own personal tesseract, stretched out from the moment you were born all the way to this very second right now.
Okay, so let's zoom out for a second. We have this clear pattern, right? A point becomes a line becomes a square becomes a cube becomes a tesseract. But here's the truly remarkable thing. This pattern doesn't just stop at 4 dimensions. It keeps going, beautifully, into infinity. The rule at the heart of all this is actually super simple. You take a 0-dimensional point and you move it. Boom, you get a 1-dimensional line. You take that line and move it perpendicularly, you get a 2-dimensional square. You move the square, you get the 3-dimensional cube, and you move the cube to get the 4-dimensional tesseract. See? Each new shape is just the path its parent took moving through a brand new dimension.
And this just keeps going and going. After the tesseract, you get the pentaract in 5D, the hexaract in 6D, and on and on. Now, don't worry about the names. Just look at the number of vertices, the corners, for each shape. You starting to see a pattern here?
Okay, here's the crucial part. It's all about the beautiful, predictable math behind this. A line has 2 corners, a square has 4, a cube has 8, a tesseract, 16. With every single new dimension we add, the number of corners exactly doubles. It's this perfect, infinite pattern of structured growth.
Okay, but what if this wasn't just a cool thought experiment in geometry? What if this pattern is actually built into the laws that run our physical universe? Because, well, this whole idea of the square shows up absolutely everywhere.
I mean, just look at the fundamental equations of reality. The energy of something moving, it's proportional to its velocity times squared. The force of gravity, or how bright a light is, it drops off with the square of the distance. Even when you get into the wild stuff like relativity and quantum mechanics, reality is defined by things that are squared. It's inescapable.
So what does that tell us? It's something pretty profound.
The square isn't just a shape on a piece of paper, it's like a fundamental principle. The actual intensity of reality, whether you're talking energy or forces or even probability, seems to be hardwired to this concept of squaring. It's like the signature of how we measure the universe.
All right, let's bring this all together. We started with a simple 2D shape, we journeyed through space-time, and we landed in the fundamental laws of physics. So what does all this tell us about the actual architecture of reality?
Well, on the one hand, in pure math, these hypercubes have become amazing tools. They help us understand super complex data, they're even powering artificial intelligence. And then, and this is the wild part, over in theoretical physics, you've got things like string theory, which propose that the universe doesn't have 4 dimensions, but maybe 10 or 11. And the reason we don't see them? They're thought to be curled up, super tiny, but totally essential to the fabric of reality.
And that brings us to this final thought. The square is so much more than just a shape. It's really a symbol for expanding order. It kind of represents our own journey of understanding, starting from the simple, stable things we can see and reaching into the invisible, but still structured, depths of what's possible. From a simple square, we really can find a blueprint for the entire cosmos.